The universe is about 13.8 billion years old, but not everything inside it formed at the same time. Some objects appeared only moments after the Big Bang, while others were born just yesterday in cosmic terms. By studying different ages across space, astronomers can read the universe like a timeline. Every star, planet, and galaxy acts like a fossil, preserving a specific chapter in cosmic history. The first objects to exist were not stars or galaxies, but simple particles. Seconds after the Big Bang, the universe was a hot ocean of energy and elementary matter. As it cooled, protons and neutrons formed, eventually combining into hydrogen and helium. These basic elements became the building blocks of everything we see today, marking the earliest physical structures in existence. Hundreds of millions of years later, gravity gathered gas into the first stars. These ancient stars, called population Roman III stars, were enormous and short-lived. They contained almost no heavy elements because none existed yet. When they exploded as supernova, they created the first metals in the universe, seeding space with materials needed to form planets and complex chemistry. Soon after, the first galaxies appeared. They were small, chaotic, and extremely bright. Unlike modern galaxies, they form rapidly and merge constantly. These early galaxies shaped the large-scale structure of the cosmos, creating filaments and clusters that still define the universe today. Observing them allows astronomers to look billions of years into the past. Some of the oldest surviving stars still exist today. They orbit the Milky Way's halo and contain almost no heavy elements. These stars act like living fossils, preserving conditions from the early universe. By analyzing their chemistry, scientists can measure time itself, determining how long ago the first generations of stars lived and died. Globular clusters form next, tightly packed groups containing hundreds of thousands of ancient stars. Many are over 12 billion years old, nearly as old as the universe itself. Their stability allowed them to survive cosmic collisions and galactic evolution, making them reliable cosmic clocks for astronomers studying the age of galaxies. Our own Milky Way grew slowly through mergers with smaller galaxies. Over billions of years, it developed spiral arms, star-forming regions, and complex structures. Each part of the galaxy has a different age. The central bulge is ancient, while the spiral arms constantly produce young stars, showing that galaxies evolve continuously. Planets did not exist in the early universe because heavy elements were rare. Only after multiple generations of stars enriched space with carbon, oxygen, and iron could planets form. This means planetary systems are relatively young compared to the universe itself. Rocky worlds like Earth are late arrivals in cosmic history. Our solar system formed about 4.6 billion years ago from the remains of older stars. The Sun is considered a middle-aged star, not young and not ancient. Meteorites preserve the earliest material from this formation, acting as time capsules that record the moment our planetary system began. Some objects are extremely young. New stars are still forming inside nebulae today. These stellar nurseries glow with hot gas and dust, showing that the universe continues creating new structures. Even now, entirely new solar systems are being born somewhere in the cosmos. Black holes also have ages. Some formed shortly after the first stars, while supermassive black holes grew over billions of years at galaxy centers. By measuring their growth, scientists can track how galaxies evolved across time, connecting the youngest stars to the oldest cosmic structures. The cosmic microwave background is older than any star or galaxy. It formed about 380,000 years after the Big Bang, when light could finally travel freely through space. This faint radiation fills the universe and acts as a baby picture of the cosmos, showing its earliest visible moment. Quasars reveal another chapter in time. These extremely bright objects existed mainly in the early universe, powered by rapidly feeding supermassive black holes. Their distance shows how the universe looked when it was only a fraction of its current age, helping astronomers map its evolution. White dwarfs and neutron stars represent stellar old age. They are remnants of stars that exhausted their fuel long ago. Some white dwarfs have been cooling for billions of years, making them among the oldest individual objects still observable. By comparing all these objects, scientists create a chronological map of existence. From newborn stars to ancient radiation, the universe preserves every stage of its life. Time and space is not hidden. It is written into the structure of matter itself. The universe is both ancient and young at the same moment. While relics from the Big Bang still surround us, new stars continue to ignite. Looking into space means looking through time, where the youngest and oldest objects exist together in one vast cosmic story.